we are going to do a really quick review of just the basics of how to understand the regression equation itself. And because that is a little bit more basic, what I did is looked up both the questions I get most frequently asked at orals that I assume they're also asking you, and the mistakes that apparently we make most when we're publishing. Statisticians have a habit of publishing surveys of the number of ways we do our statistics wrong in psychology, and so particularly in the field of statistics, there are a number of these publications, and I know that most of us do not want to be bad examples in someone else's article. So we're going to talk briefly about those. So some of these are things that we just run into a lot that people just don't know. So really briefly, you're all aware of how multiple regression generally works, that you have here we have three predictors, x1, x2, and x3, that are independently predicting y. So the colored areas there are all squared correlation coefficients. So the amount of area that those three colored parts of the circle take up in y, if you sum those together, that would be what r squared is. So the difficulty comes when we have this kind of situation, which is what we almost always have, where we have, again, three predictors, the x1, x2, and x3, but they overlap with each other or relate to each other in some way. One question that people ask sometimes is that some statistical programs, depending on which one you use, ask you whether you want the type 3 or type 2 error term. And since that's not a term that most of us use in statistics, a lot of people don't know what that means. Type 3 error terms are what you want. SPSS is going to use that automatically in certain of its programs, but not in the general linear model part of the program. It will ask you. Type 3 error terms are when you're assuming that it doesn't matter which order you put these variables in. So if you basically want to just see how the whole set works to predict y, and you're going to get the 3 beta weights, then what you want is type 3 error terms. If you're assuming that 1 is meaningfully the first thing, 2 is meaningfully the second thing, and 3 is meaningfully the third thing, and that's how you want to put them in, and that's the only way you want the beta weights understood, then that's the other option. That's the type 1 error term. So in general, if you are trying to analyze whether you have significant beta weights, the beta weights are associated with the blue, the red, and the yellow. So the yellow is, it's here? Oh, here. Okay. The yellow is actually the squared semi-partial correlation coefficient, but if it is significant, if the squared semi-partial is significant, then the beta weight is also significant. So the size of the blue, the red, and the yellow, the parts of the overlap here that are not contributed by two things, so not including this one or this one, those are the uniques, also the squared semi-partials, also called squared parts, also called increments. So lots of names for it, and they're tested by the beta weights. First thing about the part and partial correlation, if we have two of these things already in the model, and you add this third thing, and we're just looking at this x3, and let's say that's a new 10%, that we used to have 20%, x1 and x2 had 20%, and it went up to 30%, 0.30, according to your model. Now you have 0.30 as an r squared. That 10% is the squared semi-partial. So when you talk about that, just in terms of interpreting it in your article, you're talking about the unique percentage that that variable gave. And that will be printed on the printout, and we'll show you where when we give you some examples. Partial correlations, on the other hand, are ratios. So partial correlation is this blue part over white plus blue. It's the new percentage over what was left to give. So if I already knew 80%, I added another 10, then the 10% would be the squared semipartial, but because I'd already had 80%, I only had 20 left to know, 10 out of the 20, or 50%, is the partial. So that's the distinction between those two, and according to these surveyors, when we talk about it in journal articles, we do it wrong 50% of the time. So it might be worth our looking to see how the various articles that we're looking at do it. So this is just a repeat of what I just said so that you can have that for your records if you want a reminder. But notice that there is no red, blue, and yellow, since these are from my student handouts and there's no red, blue, and yellow. So you do have to note for yourself that it's the areas that don't overlap that are the red, blue, and yellow that we're talking about that are tested by the beta weights. You're all familiar with beta weight equations, what they look like. The intercept here, and then the beta weights here for x1 and x2.
Regression weights or beta?
Both. Yeah, these are raw. These are raw regression weights. They could be either standardized or non-standardized beta weights, but we'll get to that in a second. So these, the mean difference in y for each 1 unit difference in x is what a B weight would mean. So standardizing and centering are both linear transformations of the beta weight equation. You're all familiar with standardizing. You can either take the z-score of the variable and then just put it in to a regular regression equation so that you will then have standardized weights, or you could get the standardized beta weight out of the table. And there's reasons why you would sometimes want to use a transformation to a z-score that we'll get to. Centering, though, centering is when you subtract some value, not necessarily the mean. It's called centering, even though technically it isn't centering. If you subtract anything from that score, you might not want to subtract the mean. You might want to subtract some other clinically interesting value, so that if you center on or subtract something like the clinical cutoff, then what that's going to do is allow you to make a judgment about what the what predictions are made at that point in time. So I'll show you an example in a minute. Standardizing makes the variable with different metrics comparable, so that if you have standardized beta weights of 0.4 and 0.5, the 0.5 is always the bigger of the two. It's stronger of the two, the more significant of the two. Trouble is, you're not supposed to standardize dummy-coded variables, and a lot of times you have a dummy-coded variable in your model. So technically what you're supposed to do is run it the regular way, the raw score way, and then transform just the ones that you want to be standardized into standardized beta weights for yourself when you're comparing them in the article. So you can simply run it two ways so that you can have those two standardized beta weights for for instance, if you had two standardized beta weights and a dummy code, then you're supposed to present in your article the raw score beta weight equation. But then you might say in your text that the standardized beta weight for this one is this, and that one is that, and therefore this one is the stronger one of the two. But because you can't get the computer to standardize one and not another, you have to make a choice. And technically, you're not allowed to standardize a dummy code. A dummy code, everybody know what dummy codes are? Student folks know who remember dummy codes? Okay. Okay, so if you did do it the raw score way and you want to turn certain of the coefficients into beta weights, into standardized beta weights separately, you can do it very easily by just multiplying the raw coefficient, the regular B weight, by the standard deviation of the relevant X divided by the standard deviation of Y. It's really easy. So you can individually do that so that you can make those. This is apparently one of the top mistakes we make according to the statisticians who critique us all the time. Why would you want to center? It changes the meaning of the intercept, basically, if you center something. The intercept, if you don't do anything, the intercept is the average value of Y when all the X's are zeros. But you might be predicting PTSD from dissociation. Maybe there is no zero. Or physical health, mental health, I have as an example here. Well, there is no zero. So the intercept then is not a meaningful value. If you center it, you can, and you subtract the mean, for instance, the intercept changes so that it means the average value of Y when all the X's are at their mean or their clinical cutoffs or whatever it is that you're doing. That might be a really interesting figure for you, depending on what it is you're studying. That the average value of Y at the mean of some set of clinical instruments is whatever it is. It tells you something about the sample that you have. So this is just an example of centering. It's a pretty famous data set, mental health and physical health, big national sample, to show the distinction. This is the line, and this line here is where the computer would put the intercept, so that would be where it would be measuring how the line is doing. And we really want to have it measure how the line is doing over here, where everybody really is. So centering would allow us now to put the intercept right in the middle of where everybody is. And so that's usually a helpful thing to do. Another thing that apparently we do incorrectly about 70% of the time, according to our statistician critics, is not handling quadratic terms right. And since they're really very easy to put in, all you do is include x squared here. So all you have to do is, if you think x might be both linear and quadratic, so it goes like that, which is a really common thing in psychology, to have some point where the thing tapers off or levels out. All you have to do is have a column in your data set where you have x and another column where you have x squared, and put both of them in the model, and it will introduce a quadratic term and a linear term. So our critics, in saying that we do it wrong, typically mean that we didn't do it. We didn't do it at all. And that we presented our little regression scatter plots, and they could see that there was a quadratic term in there that we didn't bother to look for because we just tend to be pretty linear in psychology. That way, if you get plots that look like that, that's a downward slope in general, downward regression slope. So the line is generally downward. But B2 is negative in the first place, that the curve itself is curving negatively versus curving positively. So then if you can get all combinations, of course, of negative and positive, negative, positive, zero, negative, zero, positive. But it obviously gives you interesting and additional information that we could use. The next most popular thing we apparently do wrong is interpretation of logs, and according to the surveys, we do this wrong 70% of the time, which is a big base rate. And I've seen this too, and this is just the reminder here is that once you log transform something, it no longer works to think of the beta weight as doing what it almost always does in every other circumstance, where 1 unit up on X means such and such an amount of unit up on Y. So here is just a reminder that if you do a log transformation on any of the X's, then the beta weight over 100, the difference in Y for every 1% difference increase in X. So the beta weight over 100 means the difference in Y for every 1%, not 1 unit, difference in X. And if you log both of them, then B means the percent change in Y for 1% change in X. So it turns things into percentages, basically. And that's just something you'd have to write down and put somewhere because it's easy to forget how the logs work. And the interaction is the last piece and then we're going to show you a specific example of it. This is the way the interaction beta weight formula looks. So again, you have the intercept, you have the two component, the X and Z is what they're using in the statistical literature, as opposed to X1 and X2, which is what we usually use. And then the interaction, which is multiplying the two here. We'll talk about centering them first, which is the common thing to do and which we both do. The statisticians now say you don't need to center. We're not forced into centering. It's just easier to interpret if you center. It's not wrong if you don't center. But in terms of interpreting it, if this has a positive beta weight, then as this one gets larger, this slope gets more positive, and as this one gets, as Z gets larger for a negative beta weight, as this gets larger, then this one gets more negative. So depending on the sign of this, you can use this to predict what happens to this. And basically, the problem in terms of interpretation, that works pretty well. Most people interpret that part right because basically they're just saying if that's significant, if this is significant here, you have an interaction. And then you plot it, and then you can see what's happening, and so you're unlikely to make an egregious error. The error that we make, according to the critics, is that at times we misinterpret these two, that because we think of this as the interaction, it is the interaction, we wrongly think of these as the main effects, and they're not. So that you cannot think of these two as main effects because these beta weights are really what happens to X when these are 0. They're not the average way in which Y and X or Y and Z are connected. They are the way in which they're connected if you zero out the other two. So because of that, they're really a form of simple effect. They're not really the main effects. And therefore, you can make incorrect interpretations of this by assuming that because these guys are significant, there are just main effects, and because this is significant, there is an interaction. So what you're supposed to do really is run the thing, plot this out, make your statements about the interaction if there is one, and then if you want a statement in the regression terms about your main effects, you take this out and you run it without the interaction. And then you can make a statement about how your main effects worked. But if there is an interaction, you always want to talk about that first anyway. Okay. And so this is a reminder of that the first order beta weights then, the B weight of X means the slope of YX at the mean of 0 or mean of Z or 0 if it's not centered. And B weight of Z slope of yz at mean of x, or 0 if it's not centered. So I think that's the low-level overview. And now we'll get into how do you do the math of the interaction.
So we're going to talk about mediation and moderation.
Oh.
Before we do, since we just talked about interactions, basically when we're doing, oops, how do you want to do it, Omar? I'm going to flip it over. Thanks. So just the thumbnail sketch we'll talk about in much more detail. So mediation is when you're assuming that some variable is the causal or inferred causal link between two other things. A causes B causes C. And we're going to see how we can test that later. Moderation is the same as interaction. That some B variable moderates the effect between A and C. We'll show you, in your package, you'll see some models of that. So the first thing you should always do is test for moderation, because if you have moderation, you may want to alter your conclusions about mediation. So the current recommendations are always test moderation first, which is to say test the interaction effects, which we're going to do right now on a specific real example. So in this example, this was a study where people were asked to rate the symptoms they had after a specific trauma. Specifically, did they have any intrusive thoughts immediately after the trauma, or did they have any dissociative type symptoms right after the trauma? Then these folks are followed up later with a much more complete PTSD evaluation, and we're trying to see do evidence of early intrusion and early dissociation predict worse PTSD symptoms later. Right, and it's a good one because it has the interaction we want. So here's the variable view for this data set. Here's the data view. If anybody really needs more time on how to do it, we can show you how to do them, but I'm just going to quickly go ahead and analyze it. So you'll see we use linear regression. The dependent variable is the PTSD symptom. And remember we talked about centering, so we're going to use centered intrusive thoughts and centered dissociation, which means we subtracted the mean from each of those. So now the mean of each of those is 0, and there are standard deviations in each side for each of those scales, just to take care of the centering part of it. On regression, we always use all of these options on the right, plus the Durbin-Watson. Continue, and there's other stuff we can talk about later I won't do now.
Can I ask you, why aren't the means 0 on centered?
I may have printed off the non-centered ones, but so that doesn't look.
Missing data? Could that be why?
No, I bet I printed off the ones that weren't centered, but they're everything. They're right. You see the means?
Yeah, the mean 0, 0, 0.
They're very close to 0.
Oh, okay.
Yeah, I mean there's always going to be some rounding.
Because when he subtracted the mean, he subtracted the mean only out to 94 degrees.
Right. So the mean score, once we centered for intrusive thoughts, was 0 with a standard deviation of about 16, and the mean for dissociation was also 0 with a mean score of about 25. You do lose something in the process of centering because now you don't know what that means in a scale, since centered variables always have means of 0. So sometimes there's an advantage of interpretation of not centering, but the regression results will be almost identical. Next we get our correlations. So on your output, I've annotated it for you. So you can see what all these things mean. We have a R squared here, 0.204, which is significant at 0.006 level. That means the equation as a whole is significant. We're 99.4% sure that the R squared is not 0. That's all that tells us so far. The Durbin-Watson is the index of whether there's any autocorrelation in the data, in the residuals. It needs to be near 2. This one is a little low, but pretty close to 2. Then there are equations actually given in this next set of, in this next box. And those are the B weights and the beta weights. And that's part. I've actually gone ahead and squared those for you on the output, so you have your squared semi-partials. So the interpretation here is a 1 unit increase in intrusive thoughts after the trauma would be likely to produce about a 0.24 increase in PTSD symptomatology with dissociation held constant. Held constant, controlled for, those are all words that people use for the partialing that goes on in regression. Another way to think about it is if we were able to get a sample with everybody with the exact same dissociation score and then ran the regression on intrusive thoughts, this is what we would get from those folks. Right? So this is a way of controlling for that. And also then for dissociation, a 1 unit increase in dissociation gives us about 0.4 increase in trauma score with intrusive thoughts held constant. If you want to put those into beta weights, those are standardized scores. So you can see that the dissociation is a little bit more than twice as important as the intrusive thoughts. So you cannot compare these, but you can compare these. We can look at significance of them. In this model, you can see the intrusive thoughts didn't reach significance by itself, but the dissociation did. The partial squared, the numbers you've got in your little output, are the unique contribution of that variable. Unique means the percentage of variance in PTSD symptoms accounted for uniquely by intrusive thoughts holding constant dissociation. I think it's 1% is what it is in that example. And I think, what's this one is, I don't have it in front of me, must be 7% or something, huh? It's written right there. 7% of the variance in PTSD symptomology is accounted for by dissociation holding constant intrusive thoughts. Got it? Any questions on that output? That's the basic output without any interactions in it yet. So if you want main effects, there they are. Okay, now I'm going to go through and add the interaction term, which I've already created. I created it just with a transform compute, made up a new term called interaction term. All it is the product of the two other terms, multiplied times each other. If anybody needs to see how to do that, I think I gave you a little handout on that. So I'm just going to add the interaction term, and that's of the two centered terms. So everything stays the same. I run it again. Now we look, as Connie was saying, it's important now to look especially for significance of the interaction term, and we get a really nice interaction significance, 0.006, which means that somehow or other, we don't know yet how, the combination of intrusive thoughts and dissociation right after the trauma, when considered together, give us much more, or very sure that they predict PTSD symptoms. And the semi-partial squared is a really nice one. It's 0.4 squared, almost 15 to 16%. So now we actually are accounting for a fairly decent percentage of the variance in the PTSD symptoms when we combine these things together. Now what we don't know at this point is how do they work? How does it work? We probably had a good idea in this case that we thought that probably the dissociation was a moderating factor for intrusive thoughts, so that someone comes in with dissociative features already, that's probably going to make them much more prone with intrusive thoughts towards trauma. But we don't really know that yet, so we need some way of doing it. So now there's a number of ways of doing this. In your handout you can see some ways that we did it. The way that we're going to do it, the simplest way to do it.
We did before, just to remind us though that what we do know is that because because the interaction is negative, we know the direction.
Yeah. So as you pointed out earlier. isn't it? Should be pretty exact.
It's just that the long table is split into two.
Oh, I see. Yeah, these just come down below. That's all. That's just the way they get printed. I think the numbers are the same. Okay, so in your handout, there's a nice little article about how to interpret interactions. There's 3 or 4 very sophisticated ways to do it. And I don't think we're going to have time to do very much of that, so we'll do the simplest one. The simplest one.
What does the negative interaction mean?
Oh, say it again, Connie.
The negative interaction just means that as you go up, it's going to have a negative impact, but as Z goes up, it will have a negative impact on X's relationship to Y.
But the easiest thing to do is to plot it and see. So the easiest way to do this, because it's really just for interpretive purposes we're going to do it, is to dichotomize the variables into, or you can trichotomize them if you want, if you have a big data set, into high and low dissociation, high and low intrusion. So make it into a much simpler kind of a problem. That'll give me the general trend of the interaction. The other way to do it is you can put an equation together where you put z-scores of +1, 0, or -1. That's a popular way of doing it, so you'll get 3 graphs. And I put one of those for this data I just hand drew it. You see my scribbles there with the 3 different things. Well, we did those with, we standardized the scores first so that it made it easier. The one we're going to do is not going to be that way. So what I did is I already went ahead and dichotomized the variables. Again, if you don't know how to do that, there's a nice little package in SPSS under transform into different variables. You recode them into different variables. You can tell SPSS to anything above the median, put into high, everything below the median, put into low, to do that for both groups. So it went through and it coded every single person on intrusion and in dissociation as either high or low, based on how I told it to do that. Okay, so now I'm going to go and do an ANOVA just to get the graph with general linear model, univariate. Dependent variable stays the same, but now I've created these variables which are called high-low somewhere. Dissociative high-low and intrusive high-low, right? And now under plots, I'm going to do, which one do we want on the horizontal, Connie? We want, which way did I do it on the graph I gave you? I forgot. Intrusive high-low?
Yes, you split up.
Intrusive's on the x-axis, right? I think so. Yeah. Okay. You could do it either way, but I mean, it probably depends on what you're thinking would happen. So now we'll be able to see where that interaction is coming from. Notice we lose a lot of power when we put people into high-low instead of having continuous measures, so the interaction is actually not significant in ANOVA. So it's a good lesson in don't dichotomize variables. If you've got continuous measures, use them as continuous. There's a lot more data there than you're going to get. And here you can see what happened, which sort of does make sense. For the people were in the blue here were low dissociatives. Presumably that would have something to do with their somewhat of a trait from their past, or depended on their developmental history possibly, that they did have a slight change in high intrusive versus low intrusive, but not very much. But those who came in with high dissociative traits, when they also had intrusive thoughts after the trauma, they got way worse trauma symptoms.
This is one of the studies that was done to show that the fact that people have intrusive experiences for like 2-3 days right after their really, really horrible experience means virtually nothing. That often happens to people no matter what's going on. But if that occurs and you're fairly dissociative, and then you try to avoid that experience for a while, then it ends up being long-term really detrimental.
Now, would you run the post-hoc tests on this?
Well, this one is dichotomized, so you could, but you're going to lose a lot of power on the process. But you can do it within regression. by just going through and doing the, separating them out into different z-scores and then actually testing the slope of the lines. So it's in the handout. It's just a little bit too involved for us to do today. So you can test significance of the slope of the line with the t-test.
But then would you present then the means that's atomized on it?
You can.
Yeah.
You can. You'll see them done every way.
The most common way is to do 3 lines, 0, 1 standard deviation above, and 1 standard deviation below. And it's just a little harder to do that.
Yeah, but it's in. If you want to see how to do it, it's in that handout. So, okay. So now, any other questions on that? That's the stuff on interactions. Interactions is testing moderation. So here we're seeing that dissociation is a moderator of the relationship between trauma and PTSD symptoms, right? We're not saying it's a cause. We're saying it moderates these symptoms. It affects them somewhat. So now we're going to talk about mediation a little bit with those models.
You have to have done that kind of thing. You would definitely not just run it and then look what.
Well, you won't, if you run it, you're not going to know the shape of the interaction. You need some way to look at the shape of the interaction. So that's why there are 3 or 4 methods available to do that. Just getting an interaction wouldn't have told us that this is exactly what's happening here. But now that we know there is a significant interaction, it accounts for 16% of the variance, Connie could make that clinical statement, which is a very useful statement for trauma clinicians, saying this is how we think it works. This is a real, very much more important finding than you would have gotten from the main effects, which is, yeah, the more dissociative you are, the worse you're going to be. That's one thing, but this is kind of putting them together in a way. And if you've been reading JCCP lately, probably half the articles are now moving towards mediation. It's a good sign for our field. We've finally gotten away from just saying, does it work or doesn't it work? We're now looking to see, how does it work? And probably half the articles in our good journals are trying to tease apart mechanisms of therapy or assessment or what we're doing. Okay? I don't think we actually have slides on the,
No,
so you have to use the handout.
Talk about these.
Yeah, so if you get out your handout, she'll go through. You want to do that?
Yeah, we can just talk about those, both talk about this as we want.
Yeah, so,
If you, the mediation moderation, the one thing I wanted to focus on most,
Just say, is that there's a website by Andrew Hayes, and is it on here? His, if you search for Andrew Hayes and then mediation and moderation, if you put that into your browser, you will get the mediation and moderation website by Stephen Hayes. Now, the deeply cool thing that is on there is a custom dialog box that you can, if you download it into SPSS and follow the instructions, which were a little bit esoteric, but not too bad. Oh, yeah, that's right, you can get there. Put Hayes in there. And then put macro. Yeah, okay, that one, yeah. So if you go to this website, and now click again on SPSS, SAS macros, those. Okay, and you scroll down. Okay, this one, process. What this is going to do, so we'll stay here for a second. Look in your packet, and you'll see you have 4 models. It'll say model 1, model 4, model 7, model 49. Meaning that there were many, many of them. And now if you just, we'll talk about this briefly in a moment, but you notice that model 1 is a moderator model. It's just 2 variables and that you think there is 1 moderator. And then model 2 is a mediator model, where you think there's a mediator between X and Y. Or model 4, sorry. So everybody have those? They look like this?
We're missing one person who's a packet. Use this packet. You're using that packet already.
Yeah. Model 7 is moderated mediation. So you have a mediator, and you have a moderator of that mediator. And now I won't even get a name to give a name to model 49. But what is very cool about this, first of all, what this program does is it has, I don't know how many, 70, I think, drop-down models. You just pick the model that is associated with yours, and this macro will be a drop-down menu for SPSS. So if you load it, it will load into SPSS. It will then be called process and be a choice in your SPSS bar. You can just then go to SPSS, pick the model you want, put your variables in the right place, and it will spit out all the relevant B rates and tests and indirect measures and whether you have a successful model in all the ways you would care. If you look, what is this?
PDF has those pictures in it, I think, right?
Yeah, but
Want to look at one of those or no?
not real. No, I think we can look at it from here. If you go back to the website. Now, if you scroll down here, it says SPSS documentation PDF macro custom dialog is here. But if you scroll up a little bit more, no, down, I'm sorry, the other way. There's one that says download a zip archive containing all versions of process. Choose that. Choose that one. And then once you get it, download it into your SPSS file. And then all you'll have to do is open it, and it will take care of itself. It will load itself into SPSS. Yeah, you go. So go to this website, which this afhayes.com. So if you go to www.afhayes.com, look for the macros, look for process, which is going to give you these. Then click the link that says download zip archive. That's right under all those. Keep right there. You just missed it, right above the red. Down there. So that will that is going to give you these options. And I can't tell you how much time it saves, for particularly if you have a complex model.
Connie, can you tell us what's the difference between this and path analysis and SEM?
Yeah.
What's the relation?
This is actually, you can get all of these steps if you're through path analysis, but you'd have to do a lot of different path analyses one at a time. So for instance, if you look at model, model 7, I would have to do an analysis where I ran X regressed on M, and then X and M regressed on Y, and then X and WX regressed on M to get all of the different things, to get all the different correct weights to put on the various lines. So you can do it, you just have to do it in a bunch of different steps. So this will just do that in in one step. And then after it does that, it will test whether the model replicates the actual data that you have and tell you whether you have a successful indirect effect and a successful direct effect. So that's where I probably need a picture of a model to show a direct.
I think it's in the PDF.
No, it's in a different PDF. So if you probably on,
Well, let's move on. So
yeah.
we can show people this.
And then how
Okay.
does SEM then relate to both?
SEM is going to test the model fit So it's just going to say the model fits or it doesn't fit. But the trouble with SEM is there's no good significance test for the model fit. You have to compare one model to another model and say that this model fits better than that model. And it can fit better, but there is also no agreed upon test for whether this model is significantly better fit than that model. It's just better. So the endpoints for the data analysis that you get are really more satisfactory here. It gives you testable hypotheses.
Because path analysis and this actually also do model fits, right?
Path analysis won't automatically give you a model fit. It will just give you all of the different weights to put on the lines. But you'll have to do many, many different paths to get the right ones. And you can get confused about which ones to put in to get which lines and which exact mechanisms. So if you, so we'll get to that in 1 second, but if you look at model 1, which is the interaction model that really Dick just did for you, that's the picture of what he did for you. So Y in this case would be PTSD, X would be intrusion, and M would be the dissociation. So he's looking to see whether dissociation interacted with intrusion to predict PTSD. So this would be the model that he would be testing. But if you look down, so that's the conceptual model, and if you drew it in your journal article, you would draw the one that says conceptual model. But statistically, if you look down at where it says statistical model, you'll see that X, M, and XM, the three things that we got beta weights for, are in the statistical model. So he's also showing you that you put in those three pieces to get the statistical beta weight model that then makes the prediction. And down at the bottom where he says conditional effect of X on Y and gives you a formula, there he's just telling you that if you really want to find the main effect of X on Y, you can't trust the beta weight, you have to do another formula. So he's just his way of saying that what we'd said before, that you're not going to get main effects out of this model. Okay, want to go to Sobel? Okay.
So once you've determined that you don't have a moderation,
oh,
so we now agree with all the experts now who say first test moderation, because you may think that you've got mediation, but you may not. So first test moderation, and then decide if you want to interpret your results as a interaction the way we just did. But let's say a lot of you are trying to test mediation. So especially if you're doing some kind of a treatment outcome study, you might want to see what's mediating the effects on depression for one group that gets CBT, one group that gets a control, and that you're trying to see, do changes in intrusive thoughts mediate it, or mindfulness changes do it. There's things you might want to test to do that. So that comes up a lot in the stuff that I do. So there's a very simple test for this, but we always first do the moderation and make sure we don't have an interaction. And in this one, what you do is you use your regression that we just did to determine the relationship between the potential mediator and the DV, and between the IV and the DV. So you do two regressions. One, you'd put both of them in against the DV. In our case, if we were testing our example for mediation, which we shouldn't, but if we were, it would be dissociation and intrusive thoughts against PTSD symptomatology. And then you do another regression with the mediator, which in our case would be dissociation as the outcome, and with the predictor being the IV being intrusive thoughts.
And it's an interesting, just in terms of the clinical facet of this, this actually was the initial controversy with dissociation. Some people were saying dissociation is necessary to get PTSD. PTSD is actually a dissociative disorder. That's what flashbacks are. There were some people who were arguing that, and therefore they thought that if you weren't dissociative, you wouldn't get the later PTSD symptoms, so dissociator would be alleviated. And other people were saying dissociation is just going to make the relationships worse. With whatever causes PTSD, it will make them worse. That's moderation. And that's what turned out to be the case.
But here's, we'll do the mediational model here so you can see how you can misinterpret this data. So what we're going to do is we're going to take the data from our regression, which you've actually got right in front of you. And what they want you to put in is the regression weight just from this to this. I'll have to do that one. You don't have that one. And then the regression weight from here to here with this one in, right? So the way it works is that you run both of them against this one, and then you take the B weight. You could do it with beta weights, with B weights, with t-tests. There's a lot of different ways to do it, and you'll see in this. And this is a little calculator website that I gave you that does the calculation for you. Okay, so we'll do it with the raw regression weights, except I've got to run one more first. And someone's got to write down the answer for me for that one real quick. So I'm going to run the one. We can still keep them centered. I'm going to take this out as the DV. I'm going to make, which one we want intrusive? No, we want dissociation, right? As the DV, and with get rid of the interaction, and intrusive thoughts as the predictor. Okay, somebody write down this number for me. We need these two numbers. What you're looking for in the coefficient is the B weight, 0.991, and its standard error, 0.178. Got it? So now I go back to that website. Oops. And there's a little calculator here. So for the A1, I want that one I just gave you. I want to put in the, it says, you can see here, A is the number, and then the S of A is the standard error. So what did I say that A was? 0.991, and its standard error was 0.178. And now the B we're going to get from the previous data, but I don't have it in front of me, so someone tell me what it is. The B weight we're looking at from the original B weight from dissociation to PTSD. What was that one? Point something? 0.365. And what was its standard error? 0.181. Okay, and then voila, calculate that. The number it gives you here is a Z score, a Sobel Z, and a significance level for that one. And this one just about made it to significance, right? Can you see those? You can't see them? What can I do to make them bigger? Let's see. I can make them bigger, can't I? No, this is not an Apple. I'm sorry, this is not an Apple product. So did everybody see what I did? So now we've got this misinterpretation possible if we're not careful, saying, aha, the initial intrusive thoughts leads to dissociation, which then leads to PTSD symptoms, which would be a really bad interpretation of this data, right? We just heard what the proper interpretation probably is.
And so you only know that's a misinterpretation because you did the other analysis.
Exactly. Exactly. Now, in some cases, it's a little bit easier. So for some of us that do kind of treatment outcome studies, you can use this little model after you've determined that your experimental group, be it CBT, biofeedback, ACT, is doing better than the placebo control group, whatever the other group is. You can do this model with sort of cheating on this a little bit by saying, okay, I'm going to do, this is going to be my, let's say it's CBT versus ACT, say. This is going to be my delta treatment outcome score. How much did everybody improve on their tinnitus So there's just a study just in JCCP this month on tinnitus, CBT versus ACT for tinnitus quality of life. So this would be how much did people improve on the THI, the tinnitus function scale. And this could be the delta of, let's say, mindfulness changes. All right, so let's say we had a measure pre and post of mindfulness, a 5-factor mindfulness score, say, and we saw how much do they improve on mindfulness, and did that change in mindfulness mediate the difference between the 2 treatment groups and this one. And you can plug that in, those numbers in, and at least get some crude version of whether or not you think those were the variables that mediated the improvement in the therapy.
The neat thing about these different examples is that you don't have to choose either between mediation and moderation. You can say that not only do I believe that mindfulness does mediate, I also think that it moderates. So that you can have something serve 2 functions at once. So back to the dissociation example, you could say, I think that dissociation partially mediates so that you're less likely to get PTSD in the first place, or more likely to get PTSD in the first place if you are high dissociated. But also, it moderates other things so that the severity of the trauma will be more likely to affect you or affect you more severely if you're dissociated than if you're not. So you don't have to make the mediation moderation decision. You can test combinations, whatever you clinically think ought to be going on. It's very common that you think that something will function both as a mediator and a moderator. It'll both make things worse in and of itself, and it will, if it's present, make other things harder to control.
So how do you know this would be a misinterpretation?
So now you'd have to, you could, with this one, now that we know there was an interaction, we could start to think about this being a moderated mediator or a mediated moderator.
So the 0.5 for beer.
Yeah, that's a significance level.
Can I just interrupt for a second to say, because there are only 3 things in the model right now, we only have mediation and moderation. So we don't have that third choice. There'd have to be something else in the model in order for dissociation to also moderate and mediate.
Yeah.
But the Hayes output will test all those things. It will give you the Sobel test with it. It'll test the indirect path.
Yeah. If you're doing treatment outcomes, though, usually it's pretty clear you don't care so much about moderation. We wouldn't really be interested in whether mindfulness moderates the difference between CBT and ACT to change tinnitus tolerance. I don't think. It's hard for me to think of it that way. Whereas if it turns out, as it has turned out in our studies so far, that mindfulness seems to be often the mediator between the 2 treatments and the outcome, it sort of gives us an idea what it is that we're doing in the treatment that may be having an effect. And often what we'll do to make it a little simpler, we'll do several. So in our case, we're looking at physiological changes too to see whether the changes with biofeedback make the changes in physiology which actually mediate the outcome. But the controversy we talked about previously is dysfunctional cognition changes don't really seem to work as a mediator in most models, which means that CBT works, but we better figure out why it works because it's not for the reason that people thought. So that's really important. If we can figure that out, we'll probably do a lot better with the therapy. So you can see sort of where we're moving towards in terms of just does it work.
What?
I'm just standing next to you so we don't have to change the microphone.
It's dissociation can moderate the relationship between severity of your trauma and PTSD, and it can also, so that is a moderation, and it also might mediate the relationship. So that way it would mean that severity made you dissociate more, and that's part of why you have more PTSD. But also, if you happen to dissociate for another reason, it makes severity impact PTSD more. So that there are two mechanisms going on in this particular design.
That I understand, but what I was asking, like I would be confused if I see that output and it is saying that there is a mediator, that some mediation is going on, and there is some interaction going on too when you're moderating output. How do I come to that conclusion that
the only way you can know is to do both. You have to do moderation and mediation in order to know, and you can't, and the rule is basically that you have to do moderation first. Just like in ANOVA, if there's an interaction, you deal with the interaction before you deal with the main effects. So you always check to see whether there is an interaction, because this one assumes that there's a linear thing going on, that severity is causing dissociation, is causing PTSD, and but this implication here means that dissociation is changing how severity relates to PTSD.
That I understand. I just don't understand when he says that we could be misinterpreting mediation.
Well, if you didn't do the test for moderation, and you just did this one, you probably would be very happy in saying, oh yes, I've now determined that dissociation
is going on.
Yeah, but
Yeah.
I think that's a misinterpretation. In this particular case, that's probably a misinterpretation. Moderation was much stronger, makes much more sense.
Basically what happens is that the Sobel almost always works if there is moderation. That if you have a big sample, the Sobel is significant even if you have what everybody calls partial mediation, which means that it doesn't entirely go through here, but it partially goes through here. If there's moderation, you almost always get partial mediation as a result. Because if there's moderation, then it's going to work part of the time. It's making this PTSD worse part of the time. And that might be enough to produce a false mediation result.
The thing we see very often is that people do studies and come in to consult with us, and they do 6 self-report measures and Qualtrics or something. And then they get some relationship between those measures. And they say, oh, I really want to test mediation to see. Oftentimes it doesn't even make any sense to be mediation. You wouldn't think one of those would be caused by another one. They're just associated. So what we want you to do is think very carefully before you make any conclusions about mediation, about could it really be that this leads to this that leads to this, as opposed to, well, they're associated with, if you fill out a bunch of self-report measures, you're going to get some correlations among them, and that may or may not mean anything about anything more than how they influence each other. So it's really important to kind of think through with your committee, what do we really think is going on here, rather than just say, I was told that I have to come in and test for mediation, and I have 6 self-report measures that I got on an online survey. And usually I can't even imagine why you would think there'd be mediation when someone comes in with that, versus having some really good theory behind it. Mm-hmm.
So I noticed in this description that it says that they recommend using this test only if there's no access to raw data. And that, I was wondering if you could say a little bit more about that. And so most of our students would have access to raw data.
They just say don't take some normative values of standard errors and B weights and throw them into this equation. You won't know much of anything. Usually we get it from our own data.
Yeah, they're basically saying you're going to get rounding errors. Don't be careful where you get these things. If you can't check them out yourself by looking at the raw data, you can't tell what the beta weights really are. It's just a protective statement about being careful you have some control over your own data.
Also, in the same paragraph, it says the SOAP test works only in large samples.
Yeah.
What is a large sample?
Yeah, well, we've had it work in situations like this with smaller samples,
It depends on the effect size.
and with big effect sizes. So, but if you
it's
don't,
all dependent on effect size.
yeah. So if you don't have a big effect size, One study we did is we compared a biofeedback intervention to a relaxation intervention for post-myocardial infarction heart patients, measuring depression as the outcome. And so when we looked at, we got very good improvement in depression with the biofeedback group compared to the other group. So big effect size in that. Becks were down to 7 in the one group and upward 25 in the other. But we also had given them a 5-factor mindfulness scale. We had a bunch of physiological data. What else did we have? We had the DERS, the affect regulation scale, and we were just interested what correlated with what made them better. And mindfulness was a really strong one, and the physiology was a pretty strong one too. What was the sample size? 26 per group. So it's not considered a large sample by their standards. But we had very significant, big effect sizes, very significant differences. So, and we basically got that published with people thinking, well, it makes sense that mindfulness changes. I mean, we're trying to make the case. We're not quite sure what the active ingredient is in this intervention, but that makes a lot of sense that could be one of them.
Basically, the Sobel test is going to take whatever the correlation is between this and this and multiply it by whatever the correlation is between this and this. So even if we have these nice big size things here, we're already getting down there, and you know correlations are oftentimes much smaller than this. So if you're having if you're testing that, if this relationship is 0.3 and that is 0.2, then the indirect effect is 0.06, and that has to be significant. So you have to have a sample that's big enough for 0.06 to be significant. And so what they're just warning you that because the Sobel involves multiplication, interaction tests, indirect effect tests involve multiplication, you are going to be testing a fairly small number. And therefore, you're going to need a bigger N in order for that to be significant.
Also giving you a little simple t-test you can do. If you look at the correlation between A and C by itself, without B in there, and then put B in, and then look at the correlation again between A and C, then you can do a t-test between those two correlations. I hand wrote that out in a little formula, which is a t-test between the difference between two correlations. If that's significant, that would be evidence for mediation in the absence of moderation. All right, do you see that one? It's just a kind of handwritten,
It's a one-page.
just a little page with my scribbles on it. That's it, yeah. That formula works and is a kind of a crude way of looking at how it works.
Can I ask you about Laura's dissertation? That's why we're here. To get free stats consulting. She has a model with 3 moderators. So that's what I conceptualized. So how would you test that in this? Would you use that the Hayes process?
Probably. It depends on how the moderators relate to each other. But he will allow multiple moderators and multiple mediators. Like 49 has a bunch of moderators.
I don't think the hypotheses are mediators. I think they're more just each one moderates.
What is it? Relationship between what and what?
It's the relationship between cannabis use and schizotypal symptoms.
And what are the moderators?
Hypotheses are initial schizotypal symptoms, which changes in, well, it's time 2. She has a time 1 and time 2. So it's time 1 schizotypal symptoms, social anxiety, and then social support.
Social anxiety, social support are the possible moderators.
And initial schizotypal scores.
Oh, initial level.
Initial level. Does that make sense?
Yeah. So you could break it down and just do them individually, just the way we just did it. See one at a time, or you can use the more sophisticated models to put them all 3 at once.
Yeah.
Really like regression, like with interaction effects, you have like a 3-way interaction.
Yeah, so that would be good. So
Yeah.
if you can, so then you have to interpret just. So you've got to dichotomize all 3 of those,
So what you'd recommend, rather than testing a whole
Well, at
model
least
like
to,
this?
well, it's better to use those.
That's what I
Yes.
understand.
Yeah, better to use those, but if you want to just get a gut feeling of what's happening, dichotomize them, and you'll have two graphs, right? An A times B at time 1, and A times B at time 2, or at C1, C2. And you can look and see where that three-way interaction is coming from, and you'll see right away how it's working. And that'll at least give you some hypotheses to work on. Then if you can get some fancier numbers out of it, you'll know what they mean. But I think without the graphs, you're kind of lost.
Just the interaction effects and then graphing.
Yeah, you just have to think of, the key is developing the right model, because as you talk about it, I'm thinking things like, well, won't the initial schizotypal affect their social skill development or whatever, and so don't the moderators relate to each other and in particular ways? So you just have to think out the way you think the model should work before you
And
pick
what
one.
social support and,
Social anxiety.
yeah, so they may be very highly negatively correlated too. So then you got to worry about multicollinearity.
Yeah.
Yeah, I don't remember. Did you look at what they're
Uh-huh.
Other methods for
I
visualizing.
think Stefania had one, and then we'll come back. Watch your camera.
So,
Go ahead.
so what is the advantage of using the SOVAL versus just running a mediation analysis in a regression? Like entering the variables and controlling for it in a regression?
It's the same. It just uses the same exact data. Just a convenient little calculator that'll do that for you.
It does do one extra step, basically. It does multiply down the road, so that if you just do the path analysis, you would have to look to see whether your mediator adds variance over what it did before, and then you would have the beta weights to put on the path yourself, and you could multiply down, just check the significance of that correlation. You'll have everything that the SOVAL does. I think it's a better way to do it, because the regression is.
Yeah,
Regression
we
is.
always make our students do them all with regressions first. Even SEM, unless we've got very clear-cut latent variables, you're really better off. You know what's really going on if you do a path analysis. Once you put those latent variables in, you don't really have a very good idea. And half the ones that I've seen, the latent variables don't work. So you're making the SEM create a latent variable out of something that's really not a very good construct at all. And then it makes a very pretty picture, but that may not really mean anything. Go ahead.
I was wondering about that quadratic. Should you always test for quadratic, and if it doesn't, if it's not significant, you throw it out? You were mentioning the importance of paying attention to the quadratic. Is it just eyeballing it on the
What
graph?
we generally say is that you should always look at your scatter plot, and that's a mistake. Because it isn't an automatic generated output of the SPSS printout, we actually see that most people don't do it. And because they don't do it, they miss multivariate outliers, they miss heteroscedasticity, they miss the quadratic trends. But if it is significant enough to affect your R squared, you can see it, actually. So so there's two reasons to put them in. One is visually you can tell there's a quadratic, and the other is that theoretically you think there'd be a quadratic. But to add the extra 1% or to get a non-significant one, people don't tend to do that. It's more that there are many, many things within psychology that if we all talked, we would say we expected them to be quadratically related, that as you get to a certain point, you don't get any more negative effect.
In what ways can you incorporate longitudinal data into these models?
Sorry?
In what ways can you incorporate longitudinal data into these models?
Longitudinal data is actually the gold standard, the best kind of data for the path analysis models. And there is actually an assumption in path analysis that everything, as you move downstream in the model, each thing downstream doesn't relate, the error terms don't relate to anything prior to it in the stream. So, like if we had a bunch of data points, we had a bunch of variables here at this point in the stream that were all relating here. There's an assumption that the error of these don't relate to this. And so longitudinally, the best way to assure that you can get the causal flow moving in the right direction is to have a longitudinal study, where we know that these things can't affect that because it's backwards in time, so it can't affect that. If you don't do it that way and you have everything measured at the same time, it is very common to violate those assumptions.
But if you want to do repeated measurements over many time periods, then you need a fancier technique like latent growth curve techniques. There's a whole bunch of fancier techniques that are designed for looking at long-term longitudinal data over many measurement periods. What Connie said would be true for just like this study where we measured the dissociation intrusion early and then saw how it affected later. That would be the best way. But sometimes you're looking at some complicated thing where you're looking at a whole bunch of stuff with many time periods, and these models don't work for that. The errors get messed up.
But to extend that, if you're looking at a change in one variable as related to a change in another variable, is doing a change score and doing a regression acceptable? What alternatives are there?
Yeah, you can kind of cheat and do that as long as you do a check for the law of initial values. So make sure that the difference score, the delta score, doesn't correlate with the initial value. If it doesn't, then you're pretty safe in doing that, and we've actually had some things published doing it that way. It's not a great thing to do. Delta scores are not a great thing to use, but like in that model we did, there was really hardly any other way to do it. You can do a fancier way that gives you exactly the same thing in HLM, but we were able to do it this way, and the editors understood it and accepted it.
What other options are there?
Well, to put it into the model. So basically what you then have is you might have back here their initial depression would be back here and would be part of the prediction of their outcome. Yeah. And so that way, when you put it in, you're controlling for initial depression when you measure final depression.
Right.
So that's actually better than using delta scores. And if you do use delta scores, you're multiplying whatever errors of measurement you have on that particular measure. So people generally recommend against it, but it's often very easy to understand. This smaller model is very easy to understand.
I always thought that the reason that you centered variables and then multiplied them to get the interaction term was because you were trying to avoid problems with multicollinearity. So
I didn't pay her. Sure.
I was just trying to explain that over lunch to various people. The reason people thought that initially is that if you take two things that like 1, 2, 3, 4, 5, and
That's X1. That's X1.
Okay, as X1, and then you take something that's correlated with it, so I use the square of it, so because we know that would be correlated with it, so 1, 4, 9, 16, 25. And now you center it. If you center these, this is going to be -2, -1, 0, 1, 2. And this, I think it's 11 that's the mean of this. This is going to be -10. This is going to be +14. Basically what's happening is that if you multiply these together, you're going to get a quadratic curve. You're going to get the largest numbers here and here. So if you look at the correlation between this and this, it's going to be 0 now. It's going to be in a linear correlation because this is going to be 20 and this is going to be 28, and the lower numbers in the middle. So the correlation between X1 and the interaction will be now 0 when it's centered, whereas up here, it's positive. So it looks like it removed it, but actually what it did is hit it by making it quadratic. And so that the regression can't see it. So what statisticians are saying now is there's no advantage to pretending that the collinearity is not there. You've just changed the nature of the collinearity, and so that it isn't as visible to inside the ANOVA, and inside the regression, I'm sorry. So that the regression coefficients will look like they don't relate, when actually they do relate, they just relate quadratically instead of linearly. So now,
but that's all, what we all learned was what you just said. And it's only recently they're sort of saying that that isn't really as justified as we thought. But they also say it doesn't hurt to center.
right. And it does make the intercept easier to interpret. And that actually is quite an advantage at times. So the other advantage, which is a little bit esoteric in some ways, but a lot of computer programs, because it's actually doing matrix algebra in its giant or little head, depending on how big a computer you're dealing with, and it's multiplying things. If you use giant numbers or teeny tiny numbers, it will actually, because of rounding, be off by more. So if you center, you can actually get more accurate results and get more replicable results because of the nature of the rounding errors that are made by the computer when it's trying to multiply 5- and 6-digit numbers 3 times times each other to do the matrix algebra.
Do you center transform variables the same as you would variables?
Logged variables? What depends on what kind of transformed. I mean, there's no reason to, really, but you can, but there's no reason to.
So you would center that.
Will it look at interaction effects?
Right.
You don't have to, but it doesn't hurt.
And I would always run it first untransformed, then run it transformed, and 80% plus time it won't make any difference. It's a big advantage to not talk about the log of schizotypal symptoms versus some scale that really makes sense to you.
Right.
So I can't remember the last time that we log transformed something that it actually made any difference in the outcome. The models are pretty robust to skewness unless it's something. The one we do is one of the Harvard variability measures is massively skewed, so that one we have to. But other than that one, it doesn't usually matter. But if you need to, you can.
It can matter.
Look at the interaction effect, would you then center the transform there?
Yeah.
You can if you want to, yeah. It doesn't even have an interpretive benefit, though, because the mean of the log of the, it starts to get complicated what that means.
Okay.
Okay,
We're
are
really
we?
out of time this time.
Okay.
Thank you. Thank you.
All right.